In this lesson, we're going to go over transformation of the square root function. So if you could label your paper like that. So you'll be able to explain how to determine the transformations using words. So you'll be able to explain what transformations are taking place. So this sheet is in Google Classroom as a reference page for you. If you would like, you could copy this down. This will help you determine what the transformations are doing to your graph. So just to review what these things mean, we saw a lot of this with absolute values, and now we're seeing it again, but I want to review with you what these transformations do. So A is a vertical stretch or compression. If A is negative, it reflects the graph over the x-axis, meaning it flips your graph upside down. B is a horizontal compression or horizontal stretch. This reflects your graph over the y-axis. The H is a horizontal translation, so it's going to move the graph left or right. H is, remember, that's the one you got to look out for. So if H is positive, it moves the graph left, and if H is negative, it moves the graph right. And then K is a vertical translation, so K moves your graph up or down. So for each of these examples, you do not need to write this slide down. What we're going to do is we're going to describe the transformation, and we're going to actually use the transformation to help us graph the function. So example 1, f of x equals the square root of x plus 2. So if you remember our transformations, we have this. A times the square root of x minus h plus k. We don't have a b value here, so I didn't write b. So when we're identifying our transformations, we're just going to go ahead and refer back to this form. So a times the square root of x minus h plus k. So this 2, notice it's underneath the radical. So this corresponds to an h value because it's underneath the radical. So the function is a blank translation, blank units to the blank. So this is a horizontal translation because it's taking place inside the square root. And it's 2 units because I have the number 2 there. And remember, h does opposite. So the plus 2 moves your graph to the left, 2 units. We could start with a parent function. So this is the parent function. So 0, 0, 1, 1, and 4, 2. That's the parent function. And we just want to move it 2 units left. So I'm just going to take my vertex and I'm going to move it 2 units to the left. So here's my vertex, 2 units to the left. So 1, 2. I'm right here at negative 2, 0. And then this is where my new graph would be right there. So the green graph that I drew is my new one. Notice this is just a rough sketch. It doesn't have to be exact. This is just a rough sketch. That's fine. So we use the transformations to help us graph the new function. Let's identify the vertex, the domain, and the range. So for the vertex, I'll do this over here. Remember, the vertex, just like with absolute value, is the point h comma k. So we're going to identify what's my h value. Remember, when we write our h value, we're going to write it as 2, but we're going to put the opposite sign. So instead of having plus 2, I'm going to write negative 2. And then the k is 0. So negative 2, 0. You could have also got that from the graph. Just look at your starting point. It's right there. So the vertex is negative 2, comma 0. The domain. So remember, this has to do with your x-axis. So if we start at the vertex, notice all my x's go to the right, meaning my x's are greater than or equal to negative 2, because that's my x value of my vertex. So my domain is x is greater than or equal to negative 2. Or in interval notation, it's negative 2 to infinity. Put a bracket around the negative 2 and a parenthesis around the infinity part. For the range, we're going to look at the y values. So I'm going to start at my vertex. And notice my green graph, all my values are above the vertex because my green graph is above the vertex. So that means my y's are greater than or equal to the y value of the vertex. So the y value of the vertex is 0. So we could also write the range. So this is as an inequality, but you could also write the range in interval notation as 0 to infinity. So example 2, we have f of x equals the square root of x plus 5. And again, I wrote the transformations in blue up at the top just so that we recall what the different transformations are. So I have f of x equals square root of x plus 5. The 5, notice it's outside the radical, so it's a k value. So remember, k moves the graph up or down, and it's going to do exactly what it says to do because it's on the outside. So the function is a blank translation. So the k is outside, so this is a vertical translation. And then it's 5 units, I should say up, and we don't need the word to the, so you can scroll that off. So this is a vertical translation, 5 units up. So let's go ahead and start by graphing the parent function. So here's my parent function, looks something like that. Now I'm just going to move it 5 units up. I'm going to take my vertex and just move it 5 units up. So it'll be here. So this is where my new graph would be. And something like that, again, is just a rough sketch. The vertex. So this is the vertex, remember, is the order pair h comma k. So h inside with the x, well, I don't have an h value, so it's 0. And my k value is 5. Remember, k is going to keep the same sign. So my vertex is the order pair 0, 5. And again, you could get this from the graph. If you just look, where is your vertex? Where is that starting point? It's right there. The domain. So remember, this has to do with your x values. So notice all my x values are greater than my vertex. So my domain is 0 to infinity. Or if you like, you could say x is greater than or equal to 0. So for the range, remember you're going to start at the vertex, and the range, notice the blue graph is all above the vertex. So that means my range is y is greater than or equal to the y value of my vertex, which is 5. So you could say y is greater than or equal to 5, or you could say 5 to infinity, like that. Example 3. So here I also wrote this our general form of our transformations in blue there. So I want you to try just to describe the transformation. We'll graph it together. The function is a reflection over the blank axis and this should say stretch, and a stretch by a factor of blank. So try filling that out. So hopefully you gave this a try. The function is a reflection over the x-axis because this is negative is on the outside. And it's a stretch vertically because this is 2 is the a value by a factor of 2. So let's go ahead and graph it. So we'll start with the parent function, look something like that. I'm going to plot the first transformation in green, just as sort of a guide for us. So the first transformation reflect over the x. So I'm going to take this, I'm just going to reflect over the x. So this is what you get when you reflect your graph over the x-axis. This basically takes it up and turns it upside down. And now for the next transformation, I am stretching my new graph. I'm stretching the green part by a factor of 2. So maybe we stretch it and it looks something like that. So again, it's just approximation, it's not exact. So the green graph helped me get to the purple graph. So I'm going to just erase the green graph just so we don't get confused. Now let's identify the vertex, domain, and range. So the vertex, remember that's h comma k. So we don't have an h value because there's nothing inside with the x, and there is no k value because there's nothing being added or subtracted on the outside. So my vertex is the order pair 0, 0. And again, you could get that from the graph by just looking at the starting point, which on the purple graph is right here. The domain, you could take what's underneath your radical and set it bigger than or equal to 0. Or you could just look and you could see that all your x's go to the right. So x is bigger than or equal to 0, or you could say 0 to infinity. For the range, you're looking at your y-axis. So if I start at my vertex, the y value of my vertex is 0. And notice my purple graph goes below 0. None of my y values go above 0. So this means y is less than or equal to 0. In interval notation, the way we say this is negative infinity to 0, because your vertex here is your highest point on that purple graph. So the smallest y is negative infinity and the largest is 0. Number 4, we have f of x equals 2 times the square root of x minus 2 plus 5. So I want you to describe the transformation, and then I want you to try to graph it on your own. So give this a try on your own. So pause the video and try this one. Hopefully you gave number 4 a try. So the description you should have is it's a vertical stretch by a factor of 2. It's translated 2 units to the right and 5 units up. So there was 3 transformations taking place, so I did each transformation in a different color. I started with the original function in here in black. The first transformation I show in green, so this is my stretch. The next one I show in purple, so this is just moving that green graph over 2 units to the right. And then my final resting spot for my function is 5 units up. So this is my red graph. So my red graph is my answer. So these other 3 just help me get to that red part. The vertex is the ordered pair 2, 5. The domain is 2 to infinity, or if you like, it's x is bigger than or equal to 2. And the range is 5 to infinity, or if you like, y is bigger than or equal to 5. So the last part is that transformations in disguise. So sometimes when we do transformations, it's helpful to rewrite what's underneath the radical to help you identify the transformation. So let me show you an example of this. This would be example 5. So I have f of x, or if you want, you can just call this y, equals the square root of 9x plus 27. So this, notice 9 and 27, those are both divisible by 9. And 9 is a perfect square. So I'm going to divide both of those by 9. When I do that, I get the square root of 9 times x plus 3. So remember, we have a product property. I'm multiplying here. It's really multiplication. So I could do the square root of 9 times the square root of x plus 3. Well, the square root of 9 is 3. And the square root of x plus 3, we don't know that. So we'll just leave it. So this is how I would rewrite it, so that it's in a form that I could easily identify the vertex and I could easily identify the transformations. So if you can pull out a perfect square on the inside, then you need to pull out the perfect square. So if we identify our a value, here is the value out front. Our a is 3. There is no b value. Our h, here it's positive 3, so I'm going to write negative 3. So I'm changing the sign. And there is no value being added or subtracted on the outside. So this is, my transformations are an a and an h. So describe the transformation. A, so the 3 is a vertical stretch by a factor of 3. And the h, the negative 3 moves the graph left 3 units. Notice I already accounted for that negative sign. So let's do another one. So again, we could write this as y equals. So I have 36x plus 72. So notice those are both divisible by 36. So I could rewrite this as the square root of 36 times x plus 2, because 72 divided by 36, 2. So if I redistribute this, I'd get 36x plus 72. And now apply your product property. So I'm multiplying these two, so I could take this as the square root of 36, and this is the square root of x plus 2. Square root of 36 is 6, and the square root of x plus 2 we're just going to leave as x plus 2, square root of x plus 2. So let's identify our a, b, h, and k. A, the number out front, is 6. There is no value in front of x now, it's gone. H is, here it's positive 2, so I'm going to write negative 2. And there is no value outside being added, so there is no k. So our transformation description here is it's a vertical stretch by 6 and left 2 units. So notice I already accounted for changing the sign here when I wrote my H value. So it is left 2 units. So there is a practice assignment for you to do in MathXL. It's called square root transformations. You should be able to do that assignment.